So the first thing we're going to do, we're on the back of page 19, and we are going to sketch this rational function. Now, we have actually talked about this, you and I, earlier this year. So some of this is going to sound very, very familiar. We are going to have a vertical asymptote in our picture. Can anybody tell me where the vertical asymptote is going to be? Can you remember from earlier this year? Harry?
X equals 1.
No. Look at your equation. Yeah, look at your equation. There's no ones in there. It's x equals something.
Oh, I was thinking it was the...
Oh, that's your horizontal asymptote. Yeah, we're going to get that in a minute. Erica?
X equals -2 and positive 3.
You have one vertical asymptote, and it's x equals positive 3. Now, why isn't x equals 3? Because what happens if you put a 3 in for x? You get a 0 in the denominator, and is that allowed? No, 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 no. We're never allowed to have zeros in the denominator. So, obviously we've forgotten some stuff we learned before. We're not going to relearn all that. You're going to make a note. Vertical asymptotes, denominator equals 0. So how do you find a vertical asymptote? It's where the denominator equals 0. Okay, you need to know that. So you just memorize that. Now, the horizontal asymptote, Harry already said, was at y equals 1. And that's because when you look at your problem, you have x over x. And what is x over x? If you had a problem that was 2x plus 5 over x minus 3, that asymptote would be at y equals 2. If you had a problem that was 2x plus 5 over 7x minus 3, the asymptote would be at 2 sevenths. 2 sevenths. So how am I going to write that so you'll remember it? That's how you find the horizontal asymptote. Compare highest powers. That means 2x over 7x.
When there's an x squared,
If they were squared, it would be 2x squared over 7x squared. It would still be 2 sevenths.
Well, no, like I was saying, they're different.
If they're different, let's go ahead and review those rules too. If they're different, if the highest power is on the top, no horizontal asymptote. If the highest power is on the bottom, it's y equals 0. So I'm not going to keep talking about those. We learned that before. You make a note of it and get it learned if you've forgotten. So one more time, because I'm not talking about it anymore. If the highest power is on the top, there's no horizontal asymptote. If the highest power is on the bottom, it's y equals 0. Now we also have to get our intercepts in the picture. Now, our x-intercepts are also called zeros or roots. There's more than one word for x-intercepts, in other words. And your x-intercept is a point where the y-coordinate is 0. It's on the x-axis. So I'm going to go up to my equation, and I'm going to say, okay, y is 0. how would I solve that equation? Multiply both sides by x minus 3. Those are going to cancel. What's going to happen over here? This is a multiply by 0. What happens when you multiply by 0? It's still 0. So where's your x-intercept going to be? Solve that equation. It's going to be at -2, 0. Now we need our y-intercept. That's another point, but this time the x-coordinate is 0. So go back to your equation. If you put in zeros for the x's, what do you get? -2/3. Now, when I grade your paper, these are the things I will be specifically looking for. Where's the vertical? Where's the horizontal? Where are your intercepts? But somehow you have to make a graph out of this. You need to connect these dots. I think it's kind of easy on this part because you have these two dots and you can just connect them. Notice they're kind of framed by their asymptotes. They're in this box down here. Any idea what's going on over here? What? There's no shading. This isn't an inequality, so we're not shading anything. Well, let's plot a point and see what, if we can figure out what happens. It will be. This is 4. So let's put 4 in. What do you get when you put 4 into your equation? I'm just plotting a point. I'm saying, okay, I'm going to let x be 4. I get 6, which would be way up here somewhere. So this thing is like Julian said, it's the opposite picture, like the diagonal picture. Do you suppose if you were confused by that and you were on your own doing this, that you could have plotted more points? I only plotted 1. I put in 4 and got 6. Could I have plotted 5 and 6 and 7? And so if you're confused, that's what you're going to do. You're just going to plot some more points so that you have some dots to connect. But almost always, they're going to be opposite. Notice I didn't say always. Almost always, they're going to be opposite. Okay, let's try the next one. Yeah, your reciprocal function of your BFFs, yeah, has that shape. All right, here we go. Help me out. I need all my intercepts and all my asymptotes. So can you tell where anything is? The horizontal asymptote is at y equals -1. Now, where does the horizontal asymptote come from? So I'm looking right here, right? So you have x over -x. That's you. That's how you find your horizontal asymptote. X over -x. All right, you see something else. The vertical is at x equals 1. Where do vertical asymptotes come from? What makes the denominator 0? So what would make this 0? 1, right? 1 minus 1? So that's why it's at 1. Remember your y-intercept is that point. So if I put 0 in for my x's, what am I going to get? Okay, guys, this is participation sport. I need your help. If I put 0 in for the x's, what do I get? -2. Now the x-intercept, or the 0, is that point. So if I put 0 in for y, I'm going to solve that equation, right? So what do? But that's still going to be 0, isn't it? If I multiply this over here, it's still going to be 0. So where's my x-intercept? At 2. Do you have an idea what it looks like?
Yes. I was doing that. Oh, yeah.
Now, I have this huge advantage. I've done about 10 zillion of these in my life, right? You haven't. So if that confuses you, okay, hopefully you got all your asymptotes and intercepts on there. But when I started drawing things, if that confused you, what can you always do if you need to? Plot a few more points. Maybe you need to plot 1 or 2 more points so that you can get a sense of what it looks like. But I'm telling you that these almost always look like this, or like this. They're opposite each other. Now C is a bigger problem. So we're going to have a little bit of other stuff going on in C. Let's see if we can figure it out. Anybody have a thought on how we might begin? We need to be really careful with that. Let's look at our problem. Forget we're graphing for a second. Just look at the problem. What do you have an urge to do, Katie? Factor. We have an urge to factor. Oh, that's a good urge. Now, Julian, I can clearly see that I don't have just one vertical asymptote, I have 2. What will make my denominator 0? 3 or -3. So you are going to have 2 vertical asymptotes. One's at 3 and one's at -3. This picture is going to look a little bit different because there's 2 vertical asymptotes in it. You still only have one horizontal. You will always have just one horizontal. And where will it be? At 1. Now remember, your x-intercepts are points that look like this, and your y-intercept is a point that looks like this. So here we go. If I put a 0 in for my x's, what do I get? If I put a 0 in for x, what will y end up being? 4 over 9. Now what if I put a 0 in for y? Do not panic, because the beauty of having a 0 over here is When you take this and multiply it over here, it still stays 0. So you just have this left. This came over, gone. No, what makes this, how would you get 0 here? What would x be? 2 or negative 2. So you have an x at negative 2 and an x at positive 2. Solve that equation, set them both equal to 0. Oh, man. Okay, so one thing Julian's making, Julian says this kind of looks a little like a parabola shape. Would you agree with that?
Yeah.
That's pretty easy. Okay, we got that. What do you think is happening on the left and the right? Any thoughts? Well, why don't we plot a point? That's 3. Let's put 4 in. Let's go back to our original. Let's put 4 in. What's on top if I put 4 in? 12. And if I put 4 in the bottom? So that's like 1 and 5 sevenths. That's like right here. Does that help you? No?
Does it go like a parabola?
Yeah, well, not a parabola, it goes like a hyperbola. It goes like this. But again, here's what you need to remember. The asymptotes are the frame for the picture. So the lines are going to get closer to the asymptotes.
Oh, shoot.
They're not going to make a parabola like this because it has to get close to this asymptote.
So does it go
So
on the
it's
other
going to
side?
follow the asymptotes. What do you think is happening over here?
This is great.
Exactly the same thing. But if that confuses you or you're, how am I supposed to know that? Just plot another point or two and you'll figure it out.
What about the ones underneath?
Okay, now let's stop a minute and remember, these are functions.
So there can't be negative.
There can't be anything down here because if you put something down here, it wouldn't pass the blood test. When you draw these, here's my asymptote and here's my asymptote. There's 3 sections to the picture. The left, the middle, and the right. There will be just one curve in each section. So you're going to have something on the right, something in the middle, something on the left. You're never going to have something on top of something.
So can you ever have like one going down and another
You
going up?
absolutely could. Now, I know, again, I have this huge advantage, but I know it can't be this, because if it were this, and in some pictures it could be, but not here. Because if it were this, what would I have to have right there? Another intersect, and I don't have any more. That's why I have you plot those first, because these are the only places that you can touch the axis. So I can't touch it over here, because you didn't put a point over here. Does that make sense to you? Okay.
And then when you say that, just like plot another point like to help us, so you would just like choose a random number and just plug it into that equation.
Choose a random number, yes, in the section you want to know about. So now you already know what's happening in here.
Right.
So you want to pick something bigger than 3.
Okay. That makes sense.
So you picked 4, but you could have picked any. All right, one more and then we'll be done for the day, okay? Here we go. This one's a bigger one. Okay. How do you think we should begin? Zach Mon, how are we gonna begin? Factor. How's the top factor, Zach?
X.
Perfect. Jordan Walker, how's the bottom factor? First, let's take a 2 out. Both of these are divisible by 2, so we'll take a 2 out. And then what happens to that bottom? Yeah. Okay, so here we go. Go back to the original problem. This is where your horizontal asymptote is going to come from. It's not going to be at 0, it's going to be at 1/2. The powers match, you guys, they're the same powers. So you have x squared over 2x squared, that's 1/2. So you have a horizontal asymptote at y equals 1/2. When we say bottom bigger and top bigger, we're talking about the power, like x cubed over x squared. We're not talking about the coefficients. When the coefficients match, or excuse me, when the powers match, that fraction is your asymptote. So this is at 1/2. Now, what about verticals? Where are your verticals? You look at the denominator for your verticals. Where are they? 2 and -2. Now, where are my intercepts? Remember, your x-intercepts happen where y is 0, and your y-intercepts happen where x is 0. Here we go. Let's set that equal to 0. So 0, I'm doing this one, let y be 0. So x minus 5, x plus 1. Do not be frightened by this equation. You're going to take this stuff and bring it over here, right? But isn't it still going to be 0? So when you solve that, where will your x-intercepts be? At 5 and -1. There's -1. Here's 5. Yeah, you set them both equal to 0. You're solving that equation. You're setting them both equal to 0. Now, what if we let x be 0? We get 5/8, which is more than 1/2, so it's right here. This is a freaky picture. Does anybody have any idea what it's going to look like? Warren is saying, I think this side looks like this. And she's right. It's a cubic in the middle. Very good. That's the shape in the middle. Any idea about the left side? You don't have any points over there, so you'll just be kind of guessing and logicking your way through it.
Is it going to mimic the right side?
It's going to mimic the right side, but it's going to mimic it on top. Because if it were going to be on the bottom, like that one was, what would I have to have in here?
Oh, you have to go through another point.
Yeah, and I don't have one, do I? So it has to be on the top. Wow. let's talk about how we need that. Brittany, why is the middle one do that? What did you think it might go up and then come back down? Or what did you think it might do? You didn't know? Okay. Well, here's what, we kind of already talked about it, but here's what I need for you to remember. Always, once you plot these points, you cannot cross the axis, the x-axis or the y-axis, anyplace else. So clearly these points have to be connected. Now the question is, well, what do I do after here? Well, could I come back down? No, because if I did, I would have to cross, and I'm not allowed to cross. So if I can't come down, I guess I'm going to have to go up. So that's why this goes up like that, because it can't really do anything else. Now, I got a point right here. So this makes sense to me. Over here I have no points, which means I got to have a shape that approaches the asymptotes. It's got to follow those asymptotes off the page. See how it follows it up and follows it to the left, but it can't cross the axis. So it could have looked like that one does, but I don't have a point there. So it has to be the one on the top. There's a little bit of problem solving going on here, kids. You got to kind of have your brain engaged as you do it. Okay? I would anticipate that on Tuesday we will have a quiz over graphic, because we will finish this up on Monday.